Hey everyone. So we are now moving into graphing polynomials now that we know how to factor them. So take a minute and factor this. This is going to be our guess and check with synthetic division. So pause and do this one. So this one is a little harder because 24 has kind of a lot of numbers. All right, plus or minus 1, 2, 3, 4, 6, 12, and 24. So let's see how long this takes. 1, -3, -10, 24. Start with my 1. Ooh, first shot. Look at that. Wait, nope. Just kidding. I was thinking that was a 2 on the outside. Nope, that doesn't work. So it's not 1. Let's try -1. See, -1, -4, 4, -6. That doesn't work, so neither of the 1s work. Let's try 2. All right, 2. Come on, pen. So let's see. So it's 2, -1, -2. Here it is, -12. -24 gives us a 0. So we get x squared minus x minus 12 from the division. Remember, we go down by 1. Factor that. That's an MC chart. Multiply to -12. Combine to -1. That's 3 and 4 with a -4. So x plus 3. X minus 4. And then that 2 means what's that last factor? X minus 2. Right? So takes a little bit. Either use scrap paper or erase. I think when I'm doing it out on paper, I just use scrap paper so I don't have to erase all the time. Okay, so think about the last lesson. We did do a review of graphing a parabola. How do you graph x minus 5, x plus 2? What do we know? This is a parabola. What do we know about this parabola? We know that its roots are what? What are the roots of that? 5 and -2. And remember, those are the roots, so it's where it crosses the x-axis. So we've got -2 and 5. Now it just says sketch, right? Is this parabola going to be upward facing or downward facing? There's no negatives in front, so it's going to be upward facing. That was a really terrible sketch. This did not go through that point at all. So that's a sketch, right? We're not going crazy with it. What other points do we know on this parabola? So we can figure out this. If we multiply everything out, do -b over 2a. We could also find just the average, and then y-intercept. How do you find the y-intercept? If we multiplied this out, remember x squared. If we multiplied this out, we'd get that. What would be the y-intercept there? It's -10, right? Is there a way to do that without multiplying it out? If you notice, where does this -10 come from? It comes from this and this being multiplied. -5 times 2 is -10, right? Because really what you're doing is you're plugging in 0. Right? The y-intercept is 0, -10. If you plug in 0, you just get -5 times 2. Okay, so now we are going to graph a polynomial. So what is something we know about this polynomial that's very similar to parabola? We know the roots, and that's, ooh, why is this moving? We know the roots. There are 3 of them. What are they? 2, 8, and -5. So we're going to put those on our graph. So let's see. Now, you'll notice I typically don't give you an actual normal coordinate plane. We're just going to do a sketch. So I try to put the points as accurate on here as possible, but it is just a sketch, okay? So then I've got points here, here, and here. Now here's the question. Polynomials are nice and like smooth curves. So the question is this thing gonna look like this, or is it gonna look like this? We don't know, right? So what do you think we could do to figure it out? We're gonna just plug in some numbers, right? So we need to know what's happening between the 2 and the 8, like what's happening here. Are we getting a positive or are we getting a negative y value? Between the -5 and the 2, are we getting a negative y value or a positive? We also could look at the y-intercept. Is the y-intercept below or above? Past the -5, if I plug in, say, -6, is it going down or is it going up? All right, so that's how we're going to figure this out. So let's plug in, we're going to plug in numbers to the left, to like between each of them. So I would pick, you can pick any number you want. So we can plug in p of -6. What do we get there? P of 0, say p of 4, and then p of 9. So I'm picking a number somewhere over here, less than -5, so -6, somewhere between them, between 2 and -5, I just pick 0. You can pick any number you want. Between 2 and 8, I picked 4, and then anything bigger than 8. So we're going to plug in, and we don't really care about the answer, we care about the sign. So grab your calculator, plug into the equation, what do we get? So when we're plugging in, you're just going to you don't have to do anything weird. So like when I plug in -6, I'm just going to do -6 minus 2, -6 minus 8, -6 plus 5. So put that exactly the way you see it in your calculator, and what do you get? All right, so when I plugged in -6, I got -112. When I plug in 0, I get +80. When I plug in 4, I got -72. And then 9, I haven't done that one yet. Let's see, I got 98. Okay, so we don't want to plot all those, right? That's terrible. Those numbers are like way too big. So all that's really telling us is like which way the graph is going. So -5, -6 is somewhere here, so it's going to be down here, right? So that means the graph is going up like this, and then between -5 and 2, we're going to hit, at 0 we hit 80, so it's going to go up and hit 80, come back down. And then at 4, it's going to go back, it's going to go down again to -72, turn around, hit 8, and then go up. Right. So we have so we kind of put these dots in here to kind of help us figure out what does this thing actually look like. So polynomials are nice smooth curves. This is kind of an intense way to do it. I don't like doing it this way. I just wanted to show you for the first one. All right, so the end behavior is the easiest way to do this. So the end describes what is happening to the y value of a polynomial as the x value gets really large, approaches infinity, or really small, approaches infinity. So here's that last problem we just did. So we have our 8, our 2, and our -5, right? Instead of finding all those points, here's what I like to do. As x goes to infinity, so as the x value gets really, really big, what's happening to our y? So if I plug in a really big number, right, 8, something bigger than 8. So we plugged in 9 before. If I plug in something bigger, what is happening? Well, this is going to be a plus, right? Because if I plug in a number over here, say, think about if you plug in 1,000, right? That's a positive number, that's a positive number, and that's a positive number. 3 positive numbers are a positive number. So that means as we go to the right, our y value is going up. The y is positive, so it's going up. Right? Then I look at as x goes to negative infinity. So if I plug in a really, really big negative number into my equation, right? So a negative times a negative times a negative, right? What does that give you? That gives you a negative. So my y is going, and a negative y goes down. So that means on the far left, as x is going to the left, the y value is going down. All right, I'm going to erase this to make room. And then once I have those arrows, all I do is draw my nice smooth curve. So it comes up, comes down, and around, and that's it. Right? So I just figure out where are my arrows going, and then I draw my nice smooth curve between it. Okay, so let's try this one. So what are our zeros or our roots? So start with that. So we've got, this gives us a 0, our 0. We've got 3. We've got -8. And we've got -1. So those are our roots. The y-intercept, what do we get if we plug in 0? We get 0, 0 minus 3, 0 plus 8, 0 plus 1. So since that 0 is that front, it's just 0. And then the end behavior. As x goes to infinity, what's happening to our y? As x goes to negative infinity, what's happening to our y? So remember, as x is positive infinity means going to the right, negative infinity is going left. So to the right, positive numbers. I always just count. How many terms do we have? I have 4. So we have a plus times a plus times a plus times a plus. What does that equal? That equals a plus. So we're going positive infinity. That's up, right? Positive y is an up. And then when we have negatives, so again we have 4 terms. So the x minus 3, x plus 8, x plus 1. What do you get when you have 4 negatives? 4 negatives also gives you a positive, so this is also going up. So now I'm going to go through and I'm going to put in my roots. So we got -8, -1, 0, and 3. So as x goes to infinity, so I'm going to go to the farthest root on the right, and my y is going up. So I'm going to draw a curve going up. And then farthest to the left is also going to go up. So now I'm just going to draw a smooth curve through the rest of it. Make sure you go through your zeros, or your roots. So I'm going down, and then it has to come back up to -1, and goes up, back down, and that's my graph. Now, what do you notice about the curves? Notice that this guy is farther down, and these are not. Why do you think that is? The farther apart the roots are, the farther down and farther up it's going to go. So that's really important, and that's why we do that. So we want to try to be as accurate as possible. It's not the end of the world, but... Okay, I want you to pause, find your zeros, your y-intercept, and your end behavior. And then check with me before you go and sketch it. So we change the sign. Remember that we do have that negative on the outside, but that's not going to affect the zeros. So my zeros are -12, 4, and 1. The y-intercept, what do we get if we plug in 0? Let's see. So we get 12, 48, -48. The end behavior, as x goes to infinity, y goes to, x goes to negative infinity, y goes to. Okay, so now for the right, this is right, this is left. All right, so what's happening? So let's see. If I plug in a positive, so now notice again, we have that negative in front. So we have the negative in front, And then the x plus 12 is a plus. The x minus 4 is a plus. The x minus 1 is a plus. So what's that give us? A negative. So we get negative infinity here. And then again, we have that negative in front that we have to count. Now we're plugging negatives in. So I get a negative times a negative times a negative. So I have 4 negatives, which is a positive. So positive infinity. Okay, so now put on your zeros and draw your smooth curve. So I've got my negative 12 on the left, and then I got a 1 and a 4. So this time on the left side, we have a plus, so that's an up. So we've got an up, and then on the right side, we're going to, we have a down. So then again, we draw a nice smooth curve, like that. Not the prettiest job I've ever done, but you know what? It works. And we know actually this point, we can label it. What is that? Negative 48. So you can see how the scaling on these are super different. The y values go very high and very low. All right, try this one on your own. All right, so our zeros. Now this, what does that give me for a 0? 0. Because remember, basically we're setting each of these equal to 0. 1, negative 6, and positive 7. My y-intercept is 0 because of that front negative 5x. When I plug in 0, I get 0. X goes to infinity, y goes to, whoops, x goes to negative infinity. What is happening to our y? So when I plug in pluses, I have a minus 5 in the front, right? And then we have, you don't really need the 5, but a 1, 2, 3 pluses. So what's that give us? A negative. Okay, and then we have the negative 5 again in the front. And then we have minus, 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 which gives us a, uh-oh, I did something wrong. What did I do wrong? Oh, shoot, I messed this up. Ignore me. All right, erase. So we have that negative 5 in front, right? So we have that negative 5. And then how many x's are in the problem? We've got 1, 2, 3, 4. I forgot the front x, that's with the 5. So I have a plus for the 5x, a plus for the x minus 1, a plus for the x plus 6, and a plus for the x minus 7. So that's still a negative. But we have the negative 5, and then a minus for the 5x, a minus for the x minus 1, a minus for x plus 6, and a minus for x minus 7. So what do we get there? We get a minus because we have 5 negatives. So both of these are negative infinity. Both of them are going down. All right, so watch out. Count the number of x's in the problem. We've got 1, 2, 3, 4. So aside from that outside negative 5 or negative, we need 5 signs. Okay? All right, so we've got a 7, a 1, a 0, and a negative 6. And these are both going down on both ends. So down, and then we're just going to draw a nice smooth curve up, down. Ooh, you know what? Those should be the same height. Because those are 6 apart, and 0 to negative 6 is 6 apart. So they should be kind of similar. That's not very pretty. There we go. That's a little better. All right. And that's our graph. Okay. So now, what if it's not factored? So now today, I'm just giving you ones that these are actually factored by grouping. So take a few minutes and do a factor by grouping. So I'm going to divide by x squared, divide by negative 9. I end up with x squared times x minus 5 minus 9 times x minus 5. So that's x minus 5, x squared minus 9, and then we have a dots, x minus 5, x plus 3, x minus 3. Right. So then what are our zeros? 5, negative 3, and 3. Our y-intercept is nice. We can read it from the original. It's just 45. End behavior as x goes to infinity. Keep doing that. As x goes to negative infinity. All right, so we have three terms, right? So 3 pluses, nothing crazy here, is a plus. 3 minuses is a minus. So we've got 5, 3, negative 3. So this is just a regular, nice, smooth curve. Up on the right, down on the left. So I did that pretty quick, right? So you get pretty fast at these. It's actually the factoring. Once it's in factored form, these are pretty easy. Okay, so pause factor. So this one's really similar to the last one. So we got x squared, x plus 7, minus 4x plus 7. Watch the signs. X plus 7, x plus 2, x minus 2. So that's our function. So our roots are negative 7, negative 2, and 2. Our y-intercept is negative 28. You can either plug 0 in like we did before, right? 0 plus 7, 0 plus 2, 0 minus 2. Or if you look at this, if you plug in 0 for all the x's, you're left with negative 28. And then end behavior is going to be the same as the last one because it's the same problem pretty much. Right, so when I plug in positives, 3 positives gives me a positive, 3 negatives gives me a negative. Okay. So let's see, we get negative 7, negative 2, 2. Starts low, comes up. That's it. Last one. Factoring is a little harder, but you can do it. So this one we have a GCF of 9x squared. You should have paused already and did this. X plus 2. And then what's the GCF of the negative 25x and negative 50? Minus 25x plus 2. Now this one's a little trickier because we end up with 9x squared minus 25x plus 2, which is a dots, right? 3x, 3x, plus 5, minus 5. The problem is, what are now our roots? What are the roots? We got the negative 2. That's an easy one. What do we get for 3x plus 5? So remember, to find the roots, you set it equal to 0. Minus 5 on both sides. And then divide by 3. So negative 5 over 3. And then what's the other one going to be? Positive 5 over 3. Our y-intercept is negative 50. Again, it's that last term. End behavior. And again, this is the same thing. Even though those 3's are in front, right, we get a plus, a plus, a plus. A minus, a minus, a minus. The only time you really have to worry is when there's a negative in front, or these are all the factoring problems we have. We only know really how to factor the x cubed ones. We haven't done any others, so we're really limited when I give these to you. Okay, so just because those are all small numbers, don't put everything really close to the x-axis. Don't like do. That's, your picture will come out really awkward. Scale it out. So that's my negative 2. That's my negative 5/3, and that's my 5/3. Right? We don't have to go crazy with it. Again, it's going up on the right. Oops, I put up on the right, positive. down on the left, and then just draw your nice smooth curve through it. And that is it. All right, practice. Have a fabulous day.